This is Alex Groce, and this is my talk for Onward essays on letting 1,000 flowers bloom on the uses of diversity in software testing. There's a full talk, of course, that you can go to during the actual conference. I'll be doing it virtual. But this is like the 15-minute capsule version that they've asked us to record. So, what does this talk about? So, this is an essay. I'm writing an essay really is what I was focusing on, not actually giving a talk. So if you really care about the topic, I suggest you read the paper. Montaigne maybe didn't give such a great TED talk. I don't know. I'm not Montaigne, but I still think the written text actually contains more of what you want to see here. But if you want the short version to see if it's worth your time to read that, let's look at this topic of diversity in software testing. So I think we could talk about diversity at some length, but in 15 minutes, I don't think it's worth it. Diversity is good. We like diversity. As the Scotsman said, if we all like the same things, there'd be a powerful oatmeal shortage. That's the aesthetic, or there's other kinds of arguments for diversity, political, moral, etc., etc. This is about the utilitarian aspects of diversity. So how does diversity let us do certain things better in this case? So in this particular case, the idea is to find all the bugs in a software system, or at least all the important bugs. So what we would ideally like, and what in some ways our research programs tend to assume, is that there is a best way to test software, probably. In the end, when we perfect all the methods, some kind of super fancy fuzzing with better specification maybe is the best thing. Or symbolic execution with more powerful theorem provers, advances in SMT technology, multi-core, whatever, some magic thing that's going to give us a great testing method. Our experience in software testing and some more rigorous arguments suggest this is not true. There probably is no single best method of testing. Certainly, across multiple different software systems, it is very unlikely that there is a single grand unified approach to software testing that works best in all cases. But even for a particular given software system, it is very likely that, let's say, our SOSTAR system is fairly big. We care about testing something serious, not a single, binary search routine. So there are probably lots of bugs in our system. The sad fact is that probably some of those bugs would prefer, if you want to find them, that you use certain testing techniques, and others would prefer different techniques, and no single technique is best for all those bugs. So if you're practically testing a system, you need to try a lot of different things. Some of them may find bugs, but they may not find other bugs nearly as well as, those bugs that they found. In fact, there might be things where there's almost opposite approaches to testing, and this one is really good for these bugs, which is a lot of bugs, and you want to find all those bugs. But this technique is best for 2 bugs out of, say, 100. But one of those bugs is a critical security vulnerability, so you really need to do that too. So diversity here is about trying a lot of things because we don't know what's going to work best. The research on what methods are best is actually pretty sketchy, as those of you who are up on the testing literature know, and our ways of measuring this are somewhat dubious sometimes. But more than that, even if we knew that, on average, this particular testing approach produces better code coverage and more bugs, it might not be best for the most important bug or bugs in your particular system. So the essay partly is a bit of a rant. One reviewer, in fact, thought that I was sort of ranting based on past paper rejections. This actually wasn't true. I usually just write something and say, oh, this is the best method for testing, as we all tend to do. But I'm not sure that I should be doing that necessarily, but that's generally what I do. This isn't really about my personal success or failure in publishing software testing papers. I'm fairly happy with that. It is about the fact that we tend to write papers saying, I have a new best testing method, and maybe we shouldn't be doing this. We should be saying, here's something else to add to the big, Batman utility belt of testing methods. A best testing method, or even a best fuzzer, is in some ways as silly a top concept as, the best dog breed. Probably you want a Scotty for some things and a Shih Tzu for others, and an Australian herding dog if you've got a herd. Variety is actually pretty useful here. Besides the flavor of life, it also gives us actually just different tools for different tasks. And here we don't know what those tasks are. So the other thing, besides this sort of rant about we should accept more expansive arguments for why testing research is useful, is actually the idea of how, if you're a practical person carrying out a scavenger hunt, which I think is one useful way to think of software testing tasks, where, it's not like if you have a scavenger hunt and you want, in our example here, a plastic water bottle, a cigarette butt, a mushroom, an empty can, etc., you probably want to split the team up and go in some multiple different ways. The place you're most likely to find a smooth rock might not be the place that you're most likely to find an empty can, and so forth. The coins might be scattered around the parking lot of the park or whatever. So you want to split up, try some different things, go in multiple directions. So there's some mathematical things here we can talk about, the coupon collection problem and other things. But let's actually think about particular ways that if you're a tester and you don't know how to use a million different testing methods, but if you're a practical engineer looking for how to find bugs, what can you do? Well, one thing you can do is if your testing system is, say, API call sequences, you can vary the length of your test. So here's a picture of success in coverage for, as the length of the test increases, the average coverage. So for this program, I'm not diving into the details again, you can read the paper. Very short tests are really good. Later on, tests don't get so good. But, short tests are really good. Getting longer helps, hurts, but, it's just not as good as really short tests. Okay, so maybe we should always do short tests. No, here's a system where longer tests generally get better and better as you increase the length. In fact, very short tests are very bad at achieving branch coverage. Here's another system. Okay, here the pattern is similar, but then once we get past a certain length, actually your worst case scenario of test coverage goes way down. What's going on here? Well, I suspect actually these long lengths let you get into cases that sort of take exponential time or something, and that ends up eating a lot of the testing budget a lot of the time. So you actually get pretty poor testing a lot of the time at larger lengths because you run one test that takes, most of your test budget. That kind of thing. Okay, so one way to diversify testing, even if you don't have a lot of different testing methods, is to vary the length of your testing. Different bugs may live in different sweet spots as far as the test length that will best find them. This is documented in the literature. It's sort of old hat. It's been known fairly well since 2005, 6, 7, 8, sometime in there. Like the testing community realized this. We've talked about it a little, but I don't think people think about this enough. So this is a simple kind of diversity. All right, so what else is there? So there's an idea called swarm testing that's being used fairly widely now in compiler testing, and is like part of the basis for, say, the testing for Apple's Foundation DB that stores a lot of iCloud data. So the idea here is, let's say that I have 5 operations I can perform in a test, and they're represented by colors. So if I construct tests that are sequences of blocks, let's say, where I have a sort of square block that lays out in sort of array, two-dimensional array style, like 100 test operations, and I randomly select the operations. Let's say that this is testing a stack, and it's push, pop, clear, top, and I don't know, something else. Pop multiple, pop in, where you pop in items at once. And I mix those randomly, and I sort of draw a picture of what each test looks like. I get this sort of undistinguishable swamp of color. I can't even pull out where one test ends and another begins. The tests all look the same. Now let's say that I try another approach where before I begin my test of 100 operations, I take those 5 operations, and for each of the operations, push, pop, top, clear, and pop in, I flip a coin. Do I have a coin here? No, I don't. Well, I flip a coin. Heads, this operation is in this set of 100 test operations. Tails, I won't call this at all. I won't do any pushing. I won't do any popping. Whatever. Okay, you got the picture? I'm throwing out some of the test operations. Every test has a potential to not include certain things. So each test is, in a certain sense, possibly less powerful than all of these tests. So then I draw a picture here. So for one thing, suddenly we can tell one test apart from another. There's diversity in the mix of operations in each test. The other thing to notice is, let's say red is push. So we're doing a decent number of tests that are going to do 100 pushes. All they do is push, and they do 100 of them. If I had a Stack Overflow bug that required 64 pushes to trigger, up here, my chances of doing 64 pushes without hitting a clear or a pop in or a pop in between, let's call it 0. It's not 0, but it's close enough for all practical purposes. In reality, we won't hit this bug. Down here with Swarm, we'll very quickly hit it. Early in our testing, we will trigger that case. So this is basically why we would want to diversify things by modifying the operations. You can look in the paper for more references on swarm testing. It's another cheap way that, even if you don't have a bunch of testing tools, you can sort of make one testing tool act like it's multiple methods of testing. Vary the length of test, vary the mix of operations. All right, what if you're doing fuzzing? Well, a new thing that's just sort of starting to come out is ensemble fuzzing. So there are various tools that support this. They're moderately ready for prime time. So one that I'm involved in is Deep State, which is sort of a unit test like front end that supports like symbolic execution and fuzzing with AFL, libfuzzer, what you will, in sort of Google test style, where you write unit tests, but you can include things like, instead of here's a fixed number, it's a parameterized unit test. So you can include, here's a number, generate it, fuzzer or whatever. So Deep State does support ensemble testing. But it's it's interim work, it's good work, but it's not well tested. And as the fuzzers move, sometimes it doesn't work. There's recent papers on this. OnFuzz is one. I can't get their tool to work, or at least couldn't the last time I tried, but that might have been a temporary outage of their system or something. There are other options. So the idea here is, we don't know what the best fuzzer is. There's tons of research literature now on what is the best fuzzer, how do we decide what the best fuzzer is. I've studied this a lot, and I sure don't know what the best fuzzer is. Sometimes I think it's AFL, or really one of its variants like AFL++. Sometimes I think it's libfuzzer. Libfuzzer's so darn fast sometimes. Sometimes I think Eclipser can find all this neat stuff that you can't find with other stuff. Well, the idea is, again, let 1,000 flowers bloom. Diversity. You want to fuzz with a lot of different fuzzers and use the test that Eclipser is good at finding that AFL isn't. Hand them over to AFL. Let AFL explore from there to find more things. So use all the fuzzers. Use all those cores you have to run a lot of different fuzzers, not just one fuzzer multiple times. Don't put all your eggs in one basket, because, that basket may not hold all the bugs you need to find. So that's the big picture here. Software testing is really difficult. We want to find all the bugs, not just a technique that finds lots of bugs well. And the only way at present that we know, and I would suspect in the long term that we'll ever know, to do that is to use a lot of different techniques. We need diversity in testing because we don't know what we're doing, and even if we did, probably what we would find out is that a mixed strategy of multiple approaches is the best method for any particular software system. Moreover, even if there is, for any particular software system, a best approach or a best mix that would be the standard mix for that, you know what? The experimental time to figure out that best approach for a given software system, given that it's likely to be unique to it, who has the time? So what you really want to do is have an approach that incorporates diversity in your testing strategies, does a lot of different things, and tries a lot of things, including, of course, mixing in humans. Manual tests can find some bugs that other things won't. Do fuzzing. Do static analysis. Do random testing with property-driven approaches that's not really fuzzing. It isn't mutation-based. It doesn't have any history. It's just brute force. Do all kinds of things. Do some symbolic execution. Sure, it doesn't scale well now, but maybe it scales for part of your system and it's best for finding the bugs in that part of the system. Try a lot of things. So the nice thing for those of you out there who are testing researchers is this means that we're pretty safe in our jobs, because I think that if testing is as hard as I suspect it is, and if ensemble, diverse, varied approaches are the only way we can get any traction here, we're going to be busy coming up with new ways to test that are good for some bugs, even if not all, for the foreseeable, nay, the infinite future. So let 1,000 flowers bloom. Try a lot of things the next time you need to test and you actually care about finding all the bugs. And read the essay if you want more on this, if you want to read my critique of a little bit of how we treat research questions in the software testing literature. Have a nice day. Hopefully you can attend the larger talk. But if not, this is enough to give you the basic idea of what I'm doing.